Sequences. Section 3.6 is sequences, and a sequence is a set of elements, usually numbers, that are in a specific order. They're in a specific order. Each element in the sequence is called a term. Now, sequences come in all shapes and sizes. They can be arithmetic, or they can be geometric, or they can just be in some specific order. Today, we're looking specifically at arithmetic sequences. Now, notice this word. It is the same spelling as arithmetic, but arithmetic is a noun. Arithmetic is an adjective describing a sequence. And an arithmetic sequence is a special sequence of numbers that all have a common difference between them. So here we've got an example of an arithmetic sequence. 12, 8, 4, 0. So let's go ahead and find that common difference. So how do we get from 12 to 8? So 12 minus 8 is 4, and then 8 minus 4 is 4. 4 minus 4 is 0. 0 minus 4 is negative 4, negative 8, negative 12. And then the arithmetic sequence continues forever. This ... at the end is called an ellipsis. So an arithmetic sequence is an infinite sequence of numbers that continues on, all having a common difference in between them. And yes, difference meaning we are going to subtract. So here's another example. Negative 3/4, negative 1/4, 1/4, 3/4. Let's find the common difference. So to find the common difference, we just need to subtract. Negative 3/4 minus negative 1/4. So when we add the opposite here, we have a common difference of negative 2/4. So negative 3/4 minus negative 2/4 is negative 1/4. Negative 1/4 minus negative 2/4 is 1/4. Positive 1/4, because think about it, when we subtract a negative, we're really adding a positive. So let's get these next two terms. So positive 3/4 minus negative 2/4 will be plus 5/4. So the next term is 5/4. And I think you can see the pattern here. 1, 3, 5. If we add 2 more fourths, it will be 7/4. So we found the common difference. The common difference was negative 2/4, and that allows us to find the remaining terms. So, arithmetic sequences. Let's learn a little bit more about the vocabulary of sequences. So here's another arithmetic sequence. 9, 13, 17, 21, ... all the way through A sub n. So this n is called a subscript. It does not have any mathematical value. It just tells us what term we're dealing with. 9 is the first term. We will call it A sub 1. 13 is the second term. We will call it A sub 2. 17 is the third term. We will call it A sub 3. 21 is the fourth term. We'll call it A sub 4. And if we just have a final term down on the end, we don't know the actual number of the term, we call it the nth term of the sequence. So A sub 1, A sub 2, A sub 3, A sub 4, ... A sub n. Remember, the n, the 1, the 2, the 3, the 4, they are subscripts, and subscripts do not have any mathematical value. So let's keep talking about this same arithmetic sequence. 9, 13, 17, 21, ... a sub n. Let's first find the common difference. So to do that, let's just subtract. So this is a sub 1 and this is a sub 2. So 13 minus 9, we have a common difference of 4. A common difference of 4 here. So if we know a sub 1 and we know d is of course the common difference, we can write an equation that will allow us to find any term in the arithmetic sequence. We have a formula for that. Here it comes. So an arithmetic sequence formula is a sub n. Remember, n represents the nth term in the sequence that we're looking for. So a sub n equals a sub 1 plus n minus 1 times d. So take just a minute, pause the video, and write this down. You need to know it. So let's write a specific formula for our sequence 9, 13, 17, 21, ... through a sub n. So if the first term is 9 and the difference between the terms in the sequence is 4, we can write a specific formula just by substituting in 9 for a sub 1 and 4 for d. So a sub n equals 9 plus n minus 1 times 4. So think about order of operations. We are first going to distribute the 4, and that becomes a sub n equals 9 plus, we're distributing from the right, and we can do that because multiplication is commutative. So 4 times n, and then 4 times negative 1 is negative 4. So we're going to simplify this formula by combining the like terms of 9 and negative 4. So a sub n equals 9 minus 4, 5 plus 4n. This formula will allow us to find any term in the sequence. Let's try that on the next page. So using this formula that we just derived, let's find the 45th term. So instead of us having to write 9, 13, 17, 21, 25, 29, and continuing that sequence out to the 45th term, this formula will allow us to do just that. So if we want a sub 45, remember the subscript does not have any mathematical value. All we're doing is plugging it in for n. So a sub 45 equals 5 plus 4 times 45. So follow order of operations and simplify, and then we'll know the 45th term in the sequence. So multiply first. 4 times 45 is the same as 2 times 90, so 2 times 90 is 180. 5 plus 180. The 45th term in our sequence would be 185. So that is a quick video on arithmetic sequences.